I'm Anil Kumar. In this video, we have test-related questions where conditions are given to you and you need to sketch the graph of the function. In the last example, you have to also sketch the graph of its derivative. In case you want to learn from me, you can always join my classes by sending an email on the address given. Now, let us enjoy the journey of success. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. I am extremely happy to share the keen interest of students in learning from me and reviewing some test examples. Here is one of the questions which I posted earlier, and many of you will like to understand its solution. So I'm taking it once again. The question number 2 asked was, graph the graph of g of x with all of the following properties. The graph is increasing when x is less than minus 2 and when x is greater than minus 2 and less than 4. The graph is decreasing when x is greater than 4. The derivative of the function at minus 2 is 0 and the rate of change of the function at 4 is also 0. That means they have horizontal tangents at this point. The graph is concave down when x is less than minus 2 and when x is between 3 and 7. The graph is concave up when x is between minus 2 and 3 and when x is greater than 7. So a lot of conditions are given to you. As you can see here, 5 of them. We need to really understand how do we match them all and then provide a function which can meet all these requirements. Of course, this is challenging. Now, I will discuss my method of doing such questions, and that is to use rough work or guidelines. So that is kind of important to understand. So what I will use here is some guidelines. So we should do some rough work before actually sketching the graph. So when you read this question, you see some numbers coming up which are minus 2, 4, 3 and 7. So let us draw these lines indicating the interest of these conditions, and then we'll define parameters or we'll sketch roughly the graph which could meet all these conditions, right? So as you have seen here, what I've done is drawn lines at minus 2, right? I'm writing it under the graph like a rough work, right? Just to guide me, how can I solve such a question, right? So these are the x values. So x equals to these values. Then what is really happening? The graph is increasing when x is less than minus 2. So that means in this portion, the graph is increasing, correct? And when x is between minus 2 and 4, so it is still increasing from here. So what does that indicate? Well, that indicates we could have something like this here, or we could also have a discontinuity, right? So we could have a discontinuity also at this point. So this could be a discontinuous point. But then let's move forward. It says the graph is decreasing when x is greater than 4. Then all throughout the graph is decreasing. You get the idea. So these straight lines with arrows indicate the first derivative, right? So first derivative negative means graph is decreasing. Now, we are given, so we've taken care of the first two conditions to understand how it may look like. Then we have the third condition saying that the derivative at minus 2 and 4 is 0. That means it is continuous, right? 0 means it is a turning point, or it could be in this shape or it could be kind of like this or that, correct? Now at 4, we know it is a maximum because it changes, right? So we have a local maximum at 4, that means. So we do hit a point as a local maximum at 4, and at 2, it is not a maximum, but it could be like a point of inflection. You see that? It increases and then it again increases. It's a saddle point. So this is a saddle point. Since it keeps increasing, correct? So we know clearly what type of graph we are going to look into. And then let's talk about concavity now. So we have turning points or saddle point at these places, right? You may also say critical number. So this condition gives you the critical number, right? Okay, let's move on. It says the graph is concave down in interval when x is less than -2. So -2 less means concave down means kind of like this. So the graph is kind of like this. You see that concave down? And between 3 to 7. And between 3 to 7, the graph is concave down. So that is the shape of the graph. And concave up between -2 and 3 is concave up between these 2 points, -2 and 3. So concave up and then down. So that means we have a point of inflection here, right? Because the concavity is changing. And then when x is greater than 7, it is again up. So we have 2 points of inflection in this particular graph. You get the idea. Because the concavity changes. So we have 2 points of inflection. Now that gives you fairly good idea of sketching the graph. Now, I would like you to really sketch the graph. Pause the video. I hope this concept is absolutely clear. Okay, so now let me sketch the graph and see how it works out. Okay, so in the first part, it is concave down, right? And we are looking for kind of a saddle point at 2, right? So we'll make a graph which is, let's say, something like this. Now this is a saddle point. Do you see that? So we have made tangent also 0 and concave down. And now we have to go concave up with a point of inflection at 3, right? So now we are going like this, concave up with a point of inflection at 3. So point of inflection means the concavity will change, right? So concavity changes up to 7, right? And we do have a maximum at 4. So it will turn at 4. Do you see that maximum at 4? And the concavity changes. So we hit the maximum at here. So this is local maximum. At 4, correct? And then we hit a point of inflection at 7, right? So now we have this point of inflection and we can now graph this. So now we can label it as to what we really did, right? So this point is point of inflection as expected, correct? And then we do have a point of inflection here also. This point is local maximum. Here we know that the derivative is 0, right? Turning point, derivative is 0 again. So we can now see concavity and the rate of change, derivatives, application on the graph itself. Does it make sense to you? So that could be one of our graphs. There could be many graphs drawn to meet the same criteria. However, I hope you understand the approach and how can we satisfy so many conditions together. So this kind of framework, the guidelines which I said, you will always do this rough work on this side. Understand what is required, and once you do this, it becomes much simpler to sketch the graph. I hope you understand and appreciate it. Feel free to write your suggestions, and if you like and subscribe to my videos, that will be great. Thanks for your time and all the best.